Today we want to discuss some of the aspects of our test scheduled for tomorrow, Chapter 8, Sections 1 through 9. Please make sure you study your vocabulary thoroughly, and I would suggest you go through your notes in your notebook, highlight, and perhaps even make flashcards to help you with those concepts. You will also be asked to determine if relations are functions. Remember that a function is a special relation in which each member of the domain is paired uniquely with a member of the range. Basically, when listing, look at all the x values. If each x value is unique, different, then it will be a function. Number 17 is not a function. You have 2 paired with 8, and then later 2 paired with -11, whereas 18 is a function because each x value is in fact different. Number 19, this one is a function. It passes the vertical line test, meaning each vertical line that could possibly be drawn will touch only one point on the graph, verifying that each ordered pair contains a function situation. In other words, each member of the domain is paired uniquely with a member of the range. All x values are different. 20 fails the vertical line test. There are vertical lines that will contain up to 3 points on the graph, so this one is not a function. For the next portion of your test, you're simply going to be substituting the values of x indicated into the function rule. So -9 times 0 is 0 plus 8 is just 8. When writing the equation for an arithmetic sequence, we have a formula we could use, but the easiest way to do that is to determine the common difference. As you can see here, we're increasing by 3, so common difference is 3. And then for the equation, we're just going to write term equals common difference times the number of the term you're looking for, plus whatever would have preceded the first term. In this case, it's 14. You can check to make sure the equation is correct. For our first term, where n is 1, 3 times 1 is 3, plus 14 is 17. In fact, our first term is 17. To find the 100th term, let's plug 100 in the place of n. So we get t equals 3 times 100 plus 14. T equals 300 plus 14, or 314. And that would be our 100th term. There's another problem like that one. Then we have graphing a linear equation. Here you may choose any values you really wanted to for x. I gave you specific ones, but we know that every line has infinitely many points on it, so there's many values we could substitute in for x. You'll substitute each value in one at a time. This will give us -3 minus 4, or plus -4, which is -7. Substitute in 0. This will give us 0 minus 4, or 0 plus -4, that's -4. Substitute in 1, that's 3 minus 4, which is -1, and substitute in 2. That's 6 minus 4, which is 2. We'll graph those points. -1, -7 actually goes off the graph. 0, -4, 1, -1, 2, 2. And then using a ruler, we'll draw a nice line, arrows, and we'll label it. Moving on. The next question asks you to write an equation for a direct variation or proportional relationship. We know that we're going to use y equals kx as the basis of that equation. Substituting in values will allow us to figure out specifically what the constant of variation is, the k value. It states, the length a spring stretches varies directly with the amount of the weight attached. So this is the length, this is the weight attached. A 6-gram weight stretches the spring 15 millimeters. So replace y with 15, x with 6, and now we'll solve that equation by dividing by 6. We find that k equals 2.5. Okay, so that would be the value that we now substitute in for k. Y equals 2.5x is the equation. And then continuing, find the amount the spring stretches if a 10-gram weight is attached. We're going to substitute in 10 for x, and we get 25 millimeters. Find the slope of each line below. Okay, easiest way to do them if the graph is given is to count. Slope is rise over run, vertical change over horizontal change. So I'm going to go from one point to another. Rise 1, 2, 3, 4, run 1, 2, 3. So the rise over run would produce 4 over 3, and that's the slope. This one, again, counting from one point to the other, I'm going to go down 2, that's negative, down 2, 1, 2, 3, 4, 5, 6 to the right, 6 to the right, and that reduces to be negative 1/3. And if you look, down 1 over 3 leads you to another point on the line, down 1 over 3. Okay? Find the slope of each line. This is clearly slope 0. It's horizontal, it's flat. Every horizontal line has no rise, so slope is 0. This one's going to have a positive slope. We know that because it's going up from left to right. 1, 2, 3, 4, 5, 6, 7, 8 up, 2 to the right. So the slope is 8 over 2, 4 over 1, or simply 4. If you don't have a graph and you don't want to take the time to graph it, it's best to use the slope formula, which actually is defined on the side of your paper. We're going to substitute in our y values in the numerator and our x values in the denominator. So 8 minus 6 over 4 minus negative 3. That's 2 over, let's change this to plus the opposite, 2 over 7. Number 32, the line goes through these points. You would just do the very same thing. Subtract your y's in the numerator, your x's in the denominator. We'll change these to plus the opposite, negative 2 over negative 8. Reduces to 1/4, and so forth and so on. On the back of the sheet, we're asked to graph using the slope and y-intercept. Fortunately for us, this is in slope-intercept form. Y equals mx plus b. So I know that the slope is going to be 1/2. The y-intercept will be 3. We're going to always begin at b on the y-axis. So that would be here. We're going to rise 1, run 2, rise 1, run 2. We also could go down 1, left 2, because negative 1 over negative 2 is actually equal to 1/2. Two negatives make a positive. And there's my line. I'll label it. Same thing here. The slope is negative 2. I know that means over 1, rise over run. That will help me when I'm actually graphing. And then the y-intercept is 4. So begin at 4, down 2 over 1, down 2 over 1. I can do that as many times as I would like until I get the graph I want to get. Y equals negative 2x plus 4. We'll label that. Okay, write an equation for each line given the specific conditions listed. I'm given slope and y-intercept, so clearly I want to use slope-intercept form. We need to know this form. It's very important. Y equals m is 1/2. Y-intercept is 3. I'm finished. That's the answer. Y equals 1/2 x plus 3. Same thing. Slope is 0. Y equals mx plus b. M is 0. B is the y-intercept, which is 4. I don't want to leave it 0x. That's 0. So we're just going to put y equals 4. This is a horizontal line. Every horizontal line has slope 0. It's completely flat, no rise. It will have an equation y equals a number, and the only number that y could equal would be 4. The next one is more involved. We have 2 points. We cannot write the equation of a line without the slope, so we're going to begin with finding slope. Subtract your y values in the numerator, your x values in the denominator. That's going to give me 4 over 4, which is 1. So I know the slope is 1. I'm going to use the point slope form of an equation, which is y minus y1 equals m times x minus x1. So I need to decide what I want to be x1, what I want to be y1. I just used the first ordered pair for that. I could have used the second one as well. That would be fine. I'm going to substitute these numbers in. That's my answer in point slope form. I prefer slope intercept form, so I'm going to continue. Basically, we were distributing the number on the outside, the slope. In this case, it's just a 1. So I get 1 times x, and then 1 times 2. If you want to change that, you could. Almost out of room here, but I need to continue a little more. I need y alone. So I'm going to add 8 to both sides, and I get, sorry that this is in the way, but I'm going to get y equals x plus 6. And that would be the answer for number 38. Number 39, passes through the origin. Our line passes through 0, 0. It contains the point 5, negative 15. I treat it just like I do number 38. I find the slope, I use the point slope form of an equation, and then I distribute, and then I add the constant on the left to both sides, its opposite to both sides, and then I have my equation in slope intercept form, which is very helpful because we now see, again, the slope is 1, we knew that already, but we also know the y-intercept is 6, so it gives me additional information. We're going to skip 39, move on to 40. In number 40, I'm asked, again, write the equation for the line having the given graph. We can see that it clearly goes through the y-axis at 3, so b is 3. We're going to find the slope by counting. That's simply the easiest thing to do. So from here to, this is an obvious point, 1, 2, 3, 4, 5 down, 1 to the right, down 5, 1 to the right. So the slope is negative 5. I know the slope, I know the y-intercept. Obviously, I need to use the slope-intercept form of an equation. So this will become y equals negative 5x plus 3. And I'm done. And finally, your last problem asks you to graph these ordered pairs, draw a line of fit, answer a couple of questions. The first one is 154, and I'm just going to kind of quickly approximate location. 2, 100, 3, 148, 4, 188, 5, 225, 6, 260. They are almost completely linear, but not quite. So we're going to draw a line of fit. Line of fit needs to summarize the information as best we can. We're going to get as close to as many points as possible, minimizing the distance between our line and our points. I am doing this very quickly, but I would say that that'd be a pretty good line of fit. Our calculators, as we practiced in class, can give us a great line of fit using linear regression and other things. If I were doing this again, I would probably slide it a little bit because I've got a little bit more under than above. But for the purpose of this, that's okay. Line of fit. Estimate the number of jumping jacks in 3.5 minutes. This would be 3.5 minutes. Here's our minutes. Here's our number of jumping jacks. I'm literally going to, and I'll do this with yellow, I'm going to go up from 3.5 until I get to my line, and then I'm going to read across and then approximate. That's not quite 170, maybe 165 jumping jacks. Anything between really 160, 175 would be a sufficient answer. I'm going to put 165. And then I need to do the same thing for 8. So my line needs to be a little bit longer to do this. Could have done a better job on this graph, and then I look up from 8. I'm gonna go straight up. Now you can see that my line here is not long enough either. I'm gonna extend it and just see 280, 300, 320, 340, and that would be 360. So if I go across there, it's going to be a little less, so maybe 355. And they're just approximation based on my line of fit. Clearly, I could do a more accurate job if I took my time on that. And that concludes your review sheet. Please spend time studying your vocabulary, and if I can be of any help, see me before school tomorrow. Bye-bye.